Alright, so I gave you a problem, x to the fourth plus 3x squared, and I asked you a bunch of questions like determine algebraically if this is an even, odd, or neither function. So all I have to do is substitute in negative x for every x value and see what we get. Remember, if it's equals to the original function, it is an even. If it's equal to the opposite of the original function, it's an odd. And if it's not the original function, and if it's not the opposite of the original function, then it's a neither. So I'm going to put in negative x for every x value. So I have f of negative x equals, instead of x to the fourth, it'll be negative x to the fourth plus 3 times negative x squared. Negative x to the fourth basically means negative x times itself 4 times. So negative times negative is a positive, negative times negative is a positive, positive times positive is just a positive, so you're going to have x to the fourth. This one over here, same thing, negative x times negative x. This will become a negative, so I get negative 3x squared. Negative times negative is a positive. Positive 3x squared. Raise your hand if you got that. Now if I look at this problem, I have, every time I see x, I put in a negative, and I get the original function. Every time I see x to the fourth plus 3x squared, I can write f of x. I see x to the fourth plus 3x squared, therefore here I can write f of x. Notice how this problem is going back to the original function, so the answer is even. Raise your hand if you got even. Alright, graphically, let's get ourselves a sketch. And I can also go over here and get some other information that can help us. My leading coefficient is the number in front here. That's your a value. So leading coefficient basically means your a value. And this a value is a positive 1. Now, the word degree up here, I put in green. So what's the difference between the two here? They're going to say even, odd, neither function, and this is an even, odd degree function. So the key word is the difference between the two in the words is just degree, but it makes you do different things. This one over here is talking about symmetry, and this side is just talking about different aspects of the graph, so not necessarily where it folds. Now my highest degree, so we can write degree, is a 4th power. In class, is this an odd or an even? Even. Well, think back to the easiest even we know. That would be x squared. That's an even. And that graph is just going to look like a parabola. Opens up, ends up. So now if I give myself a visual, here's a couple of clues you can get from this polynomial. I recognize that there is no like plus 6 minus 2. That's my y-intercept. It's my y-intercept because if I put in x equals 0, 0 to the 4th power, 0 times 0 times 0 gives you 0. This becomes 0, and you just get that number. So that tells me that my y-intercept is going to be 0. So I know it's going to cross the y-axis here at the origin. Another clue that I can get is it looks factorable. If I look at x to the 4th plus 3x squared, it looks like I can factor out a GCF of x squared. So f of x equals x squared plus 3. You can double check that by distributing. X squared times x squared gives me x to the 4th. X squared times 3 gives me 3x squared. Now essentially what's happening here is also the idea of multiplicity. I can set this equal to 0, and you're going to get x equals 0. Now that has a even multiplicity, so there I'm going to do a kiss. X squared plus 3, this is also a multiplicity too. It's essentially an even, so you're also going to kiss there. So this would become x squared plus 3 equals 0. So x squared equals a negative, I subtract 3 from both sides, and then I take the square root. I have x equals plus or minus I radical 3. Remember, negative 1 times 3, the negative 1 becomes an I. Now this tells me that I have a real solution. It's going to actually cross the x-axis here, and this one doesn't. So give myself a sketch. Don't even have to use a graphing calculator. So I know it starts up, ends up. Just going to go ahead and right through all those. I'm going to have a bounce here, and that's the only time it actually touches this graph here. So I don't know, something like this. Maybe you have a turning point there. It's supposed to look like a W. That's what general graphs of x to the 4th. Let's take a look at my graph. X plus 3x squared let's zoom out. I want a higher y value, so I'll change my window. Y max I might go 30, count by 5s. Don't really need my x values. We also talked about how it becomes a little bit flatter. So maybe my graph looks more like that. But the idea is it's only crossing, it's only touching here. There's the kiss. And then here, it actually doesn't even touch the x-axis. So from here, I can now answer the questions about my end behavior. As x approaches, we always write what here, class? Positive infinity, so that's going towards the right. What's the last thing you touch? Up, so that would be positive infinity. Remember, if you need help, you can always write these on your axes. Up here is positive numbers, down here is negative numbers. Going towards the right is positive numbers, and then negative numbers. As x approaches, what do you always write here? Negative infinity, so when you're doing the sentence here, you should be always writing one positive, one's negative. This is going right to left. Last thing you touch is this arrow. This arrow is going up, so towards positive numbers. And now you can see how all of those come together for us to be able to talk about f of x equals x to the 4th plus 3x squared. One thing we didn't talk about is graphically. So you'll notice that I can fold my parabola on the y-axis, so that verifies graphically and algebraically.